In this video, we are going to look at the life cycle of sunscreen. There are 4 different parts in this video, which are the introduction, the life cycles, the impacts, and the conclusion. So what is sunscreen? Sunscreen is a product designed to protect skin from the ultraviolet UV radiation from the sun's damaging rays. Sunburn, skin aging, and an elevated risk of skin cancer can all be brought on by UV radiation. There are 2 different types of sunscreen. The first type is physical sunscreen, which reflects the sun's rays and rests on top of the skin. The second type is chemical sunscreen. It absorbs UV rays into the skin, then subsequently transformed into heat and expelled from the body. The history of sunscreen. In 1801, Johann Wilhelm Ritter first discovered UV radiation. Then, in 1889, Erich Johann Widmark experimentally proved that UV radiation can cause skin erythema and burns. And in 1891, Friedrich Hammer developed the first chemical sunscreen to reduce UVB-induced sunburn. After that, in 1974, Ritter coined the term sun protection factor SPF. Next, in 1980, the first long UVA filter, avobenzone, came into the sunscreen market. A study reported the occurrence of coral bleaching due to sunscreen ingredients in the year of 2008. In 2019, sunburn alert stickers came into use, which indicates when it is time to reapply the sunscreen. And in 2020, Colorescence Brush on Shield was recommended for active use alone or over makeup. Before going further into this video, let us understand what is life cycle assessment. Life cycle assessment is a comprehensive approach that evaluates the environmental impact of a product or service from its extraction, manufacturing, transportation, use, and disposal. LCA also aims to identify potential environmental impacts and assess the environmental performance of different alternatives. There are 5 stages of life cycle, from raw material acquisition, manufacturing, transporting, usage, and lastly its end of life. In raw material acquisition stage, sunscreen requires active ingredients and antioxidant ingredients. Most sunscreen contains antioxidants with different functions, but some sunscreen does not contain any antioxidant. The active ingredients for physical sunscreen are titanium dioxide and zinc oxide. Meanwhile, the active ingredients in chemical sunscreen are avobenzone, oxybenzone, and octinoxate. Antioxidants are used for neutralizing or reducing the harm caused by free radicals from sun exposure. Examples of antioxidants are vitamin C and E, beta-carotene, green tea extract, niacinamide, ferulic acid, lycopene, and selenium. In manufacturing stage, the raw materials are mixed together using specialized equipment. Emulsifiers are added to stabilize the mixtures. Then, the mixture is heated to a specific temperature to melt the ingredients. The melted mixture is then cooled down to room temperature to solidify and form a smooth consistency. The final product is tested to ensure that it meets the required standards for safety and effectiveness. The sunscreen is then filled into its final packaging, which may include bottles, tubes, or spray containers. After that, the product is labeled with the required information such as SPF value, expiry date, and manufacturer name. After manufacturing stage, it goes to the transporting stage. The sunscreen product is delivered by shipping from the warehouse or distribution center to retail stores or online retailers, where it is then sold to consumers via promotional activities. To preserve its efficacy during this phase, the substance is frequently stored in temperature-controlled settings. During the transporting, fuels and energy are used. During usage stage, sunscreen is applied to exposed skin before going outside. Based on their needs and the recommendations on the label, the user will normally apply a certain amount of sunscreen, and depending on the user's degree of exposure, how much they sweat, and other circumstances, they might need to reapply the sunscreen over time. The sunscreen may need to be removed after use by washing with soap or another cleansing agent. Lastly, in end-of-life stage, some sunscreen bottles can be recycled by placing them in the recycling bin. If it cannot be recycled, it will end up in the landfill. Certain sunscreen bottles may be reused and converted into containers for holding little objects like paper clips or bobby pins. Sunscreen products also have impact to the environment. First, swimming pools and wastewater treatment facilities produce dangerous byproducts when oxybenzone and chlorine react. Next, as part of their processing procedures, treatment plants do not successfully eliminate the chemical, and oxybenzone in sunscreen product can cause a range of harmful effects in coral and fish, including reef bleaching and death. So to reduce the impact of sunscreen to the environment, what can we do? Firstly, as consumer, we can use reef-safe sunscreen. Look for sunscreens that are chemical-free, oxybenzone-free, and octinoxate-free. These chemicals have been linked to coral bleaching and can harm the marine ecosystem. Next is to avoid spray sunscreen. Spray sunscreens tend to have a higher environmental impact and are more likely to end up in the ocean. Besides that, is to use protective clothing. Cover up with a hat, rash guard, and other sun protective clothing to reduce the amount of sunscreen needed. Furthermore, choose mineral-based sunscreen. Zinc oxide and titanium dioxide are common mineral-based ingredients found in sunscreens. These ingredients provide broad-spectrum protection and do not contribute to coral bleaching. Lastly, apply sunscreen 30 minutes before entering the water. This ensures the sunscreen is properly absorbed into the skin and is less likely to wash off into the ocean. For extra information, higher SPF does not automatically imply better protection. And remember, reapplying sunscreen is just as vital as applying the first time. Thank you for watching. Please like, share, and comment to support the video.